Today we're going to review the second part of the chapter, which is finding the zeros of a quadratic. For the warm-up, for each graph, find the a value and write the equation of the quadratic in factored form. So if you remember, factored form of a quadratic looks like this. Y equals, sometimes there's an a value besides 1, so we just solve for that, and then it's x minus your zeros. So you might have something that looks like this, where r's are your zeros. So let's look at how we do that given a graph. How do we write the equation? So for graph 1, first step, find the zeros, the x-intercepts. And so one of them looks like it's at -1. And the other one looks like it's at 1, 2, 3. All right, so we're going to write those here. Your x-intercepts. The y-intercept, we just need some other point to plug in and find the a value. And the y-intercept's nice because of the 0 for the x. So here's the y-intercept. All right, so that's at 0, -6. Okay, let's plug into factor form and solve. Remember, this is x and this is y. Oops. Okay, so here's what it looks like. Y equals a. We're going to do the opposite of the zeros to get our factors. So x plus 1, x minus 3. Okay, so we're almost done. We just need that a value. And to do that, we're going to plug in x and y and solve for a. So we have -6 equals a. And remember, these x's are zeros. So we have 1 times -3. So we have -6 equals, I'll combine like terms here. -3, or not combine like terms, but multiply. -3 times 1 is -3. And you have that a. And again, we're solving. So to get rid of the -3, if it's being multiplied, we will divide by -3. And so here a is going to be +2. And when we rewrite our equation right here, so we had our x plus 1, x minus 3. All right, so you just take this equation and rewrite it with your a value as 2. So let's write it down here since I'm out of room. We'd have y equals 2 times x plus 1, x minus 3. There's our equation in factored form. And the a value, how does the a value affect the graph? So we know it's going to be a right side up, a smiley face graph, but it's going to be skinnier or narrower than the original function. Okay, let's take a look at the next one. Again, let's find our x-intercepts. It looks like -1 and +3 again. Okay, this time our y-intercept's different. 0, -1.5. We're going to rewrite our equation. So we have y equals a. Again, opposite of the zeros are our factors. We're going to plug in for x and y. So this time we have -1.5 equals a times 1 times -3. So this is -3 right here. Let's divide each side by -3. And -1.5 divided by -3 would give us half 0.5. So half, all right. Okay, and then we write our final equation here. So y equals half of x plus 1, x minus 3. What does that do? The graph is positive, so again it will be right side up, but this one will be wider than the original function because this 1/2 value is kind of like a slope, and 1/2 would be wider than 1. Okay, things we need to know for this chapter. How do we find the zeros by factoring and with the quadratic formula? What the discriminant is and what it means, complex numbers, and how to simplify radicals with I. So we're going to review some of that today. And we're going to look at here the fireworks problem. This is what we started the chapter out with. I asked you to look at this problem right here. The city of St. Louis Park wants to add a fireworks display as part of the Parktacular celebration this year. The city needs to make sure the citizens are safe. Therefore, they need to know how far away the rockets will hit the ground from where they're shot off from. The fireworks company wants to make sure the rockets explode when it's at the top, and they need to know how long it will take for the rockets to reach the top so they can set the timing. Since there are trees and buildings, they need to know how high the rockets go. Here's the equation that gives this. So essentially what we can solve for so far is this. So here's where they're setting the fireworks off from. They're shooting it up. And this is what we can figure out how long it takes to land. Okay, so to do that, you could try factoring this. You could pull out a greatest common factor and factor it, or you could use quadratic formula. I'll use quadratic formula. That's how I would approach the problem. But again, this one you can factor and use box and circle and solve that way as well. All right, but using quadratic formula, let's find A, B, and C. So A is negative 16, B is 48, C is 160. And we plug into quadratic formula, x equals opposite b, plus or minus the square root of b squared minus 4ac, all over 2a. And remember, I would ask you to separate these parts right here. X equals negative 48 plus or minus. All right, I would ask you to calculate that discriminant. You can type that into your calculator, which I will do right now. So I get 12544 over negative 32. I might ask you, what does this positive discriminant means? And it means that there's going to be two real solutions. But now we can calculate what they are. So we have negative 48 minus the square root of that divided by negative 32. So I want to get 5. And negative 48 minus the square root of 12. Plus the square root of 12 by negative 32. Okay, so I get negative 2. All right, so what we solve for here is how long it will take for this residue to hit the ground, and that would be at 5 seconds ahead of 0. We do get a negative answer because this would be like over here, negative 2. But again, since we're starting above the ground, we're just looking at the positive answer. So 5 seconds for that to hit the ground. All right, so today we're going to do a few things. We're going to do a decimals activity and looking at the A value, but also we're going to look at the rest of the packet. So again, things you should need to know how to do, and if you don't, you can go back and review some of this stuff. For example, how do you find the zeros of each of these quadratics below? If the equation is not factorable, how can you do it with the quadratic formula? Can you find the A value? Can you find the discriminant, and what does that mean? And then can you do stuff, operations with your imaginary numbers? So we'll review that, and then we'll take a quiz on this tomorrow.